We're going to take a look at 7 more examples using SohCahToa and word problems. Again, this is a continuum of applications of trigonometry, so let's go ahead and get started. Number 1 says a ramp to a building has a height of 4 feet and the angle of elevation is 33 degrees. How long is the ramp? First thing we want to do is take a look at a picture that is a right triangle. In this case, I went ahead and grabbed one from the internet. Again, you can just draw a right triangle, and we're going to go ahead and plug in our information. We know that the ramp itself has a height of 4 feet. We know that the angle of elevation is 33 degrees, and we're looking for how long the ramp is, which is x. 33 degrees, 4 feet is opposite. X is across the 90 degrees, which is the hypotenuse. So using SohCahToa, I know that when using opposite and hypotenuse at this point, we use the sine ratio. Sine, again, is opposite over hypotenuse. And we're going to go ahead and plug in theta, which is 33 degrees, and the opposite. And x is what we're looking for. And in this case, because x is in the denominator, we're going to use division. So x equals 4 feet divided by sine of 33 degrees. So I'm going to go ahead and type this into my Desmos scientific calculator. Remember, we're in degree mode. Type in your fraction exactly as you see it. And we have 4 divided by sine of 33. And there is our answer. So let's go ahead and write down 7.34 feet. And that is solution to number 1. Number 2 says if a kite is 40 feet off the ground and the string holding the kite is 42 feet long, what is the angle of elevation to the kite? So here's a kite, and we're going to draw a right triangle. We're going to go ahead and plug in our 40 feet off the ground. We're going to plug in the 42 feet of string, and we are looking in this case for the angle of elevation, which we'll call theta. So again, 40 feet is the opposite. Across the 90 degrees is the hypotenuse. And using SohCahToa, we know we're using sine again. So let's go ahead and write in our information. Sine theta equals opposite over hypotenuse. Sine theta is 40 over 42. So in our calculator, because we are looking for theta, remember that when we're looking for an angle, we use a different function, which is the inverse functions, and that's sine inverse, cosine inverse, and tangent inverse. So in our calculator, we're going to type in sine inverse of 40 divided by 42. So let's go ahead and take a look at our decimals calculator and type in that information. Make sure you're in degree mode. We go to function. We go to sine inverse. We go back to the main menu. We type in our fraction, 40 divided by 42. And I click closing the parentheses. I kind of closed it in the wrong spot there, but you'll see it that we get our answer. And let's take a look. I rounded to the nearest degree and got 72 degrees. All right. Number 3. A 15-foot ladder is leaned against a house. If the base of the ladder is 4 feet from the house, what angle does the ladder make with the ground? So here is a house, here's the ladder, and we're going to go ahead and plug in our info. 15 feet ladder away from the house by 4 feet, and we're looking again for the angle of elevation. So let's plug in what we know. 4 is adjacent this time. 15 is still across the 90 degrees, which is the hypotenuse. And again, using SohCahToa in this case, I know that I will be using adjacent hypotenuse, which is cosine. So cosine theta equals adjacent over hypotenuse. Plug in what we know, and we have cosine theta equals 4 over 15. So again, we're looking for an angle, so we're using cosine inverse of 4 over 15. And we're going to plug that into, again, our decimals calculator. Function, cosine inverse, back to the main menu, make sure you're in degree, type in your fraction, and there's our solution. So theta equals 274.5 degrees. Example number 4, a kite is flown 240 yards of or is flown with 240 yards of string. The angle of elevation of the string is 55 degrees. How high above the ground is the kite? So we have a kite. Here is our right triangle. The string itself, we're going to go ahead and plug in the information, is 240 yards of string. We know the angle of elevation, which is 55 degrees, and we're looking for how high above the ground the kite is. So the x is our opposite, and across the 90 again is our hypotenuse. So again, sine is opposite and hypotenuse, so that is what we're going to be using. Plugging in our information, we know that sine of 55 is going to equal 2x over 240. Since x is in the numerator, we're going to multiply 240 by sine of 55 degrees. So we're going to type that into our calculator just like we see it. So 240 times sine, and then again, we'll type in our degree. So we got 55. I like closing the parenthesis, and we get our answer. So let's go ahead and write down our answer. X equals 196.6 yards. Number 5, in a large theater, the stairs have an angle of elevation of 27 degrees. If the theater is 50 feet long, how tall is the highest seat? So here we have a right triangle. So the angle of elevation to the highest seat is 27 degrees. The theater is 50 feet long, and we are looking for where the highest seat is. So opposite and adjacent is what's given. So opposite and adjacent, we haven't seen this yet in this video, is tangent. So plugging in what we know tangent of 27 degrees equals to x over 50. And again, in our calculator, we're going to multiply 50 times tangent of 27 since x is in the numerator. So let's go ahead and type in our information in our calculator. 50 times, again, we're in degree mode, tangent, and type in your degree. And there's our answer. So we end up with the height of the highest seat is 25.5 feet. Number 6, a right triangle has one leg that measures 8 feet and another that measures 15 feet. What are the measures of the acute angles? So here we have a right triangle. In this case, we are going to be looking for two answers. They gave us a leg is 8 feet, the other is 15 feet, but they want the acute angles. So that means we are looking for two angles that are left over in the right triangle, which is this symbol up here, we call that alpha. That's a Greek letter. And then we've been dealing with theta already. So what we're going to do is we're going to find theta first. And so to theta, 8 is the opposite, 15 is the adjacent, and using SohCahToa, opposite and adjacent is tangent. Plug in what we know. Tangent theta equals to 8 over 15. And again, we're looking for an angle, so we're going to be using the inverse of tangent. So that's tangent inverse of 8 over 15. Type that into our calculator. So again, we got to go to function, tangent inverse, go back to the main menu, make sure you're in degree mode, type in your fraction. And there's our answer. So let's go ahead and write down our answer. Theta equals to 28.1 degrees. Now remember I said that we're looking for two answers. We just found theta. We now need to find alpha. So to find alpha, remember that in all triangles, their angles add up to 180 degrees. So right now we already know that one of the angles is 90 degrees. We also found out that the other angle is 28.1 degrees. So what I'm going to do is I'm going to go ahead and add 90 plus 28.1. And that gives me 118.1 degrees. Therefore, alpha, by taking 180 and subtracting 118.1, that leftover number is going to be alpha. So alpha equals 61.9 degrees. Again, you can add alpha, theta, and 90 degrees, and you end up with 180 degrees. And here we are at our last problem. This is a challenge problem. It says you are at a parade looking up at a large balloon floating directly above the street. You are 60 feet from the point on the street directly beneath the balloon. To see the top of the balloon, you look up at an angle of 53 degrees, and to see the bottom of the balloon, you look up at an angle of 60 or 29 degrees, excuse me. Estimate the height h of the balloon to the nearest foot. So notice how the balloon here in the picture does not hit the ground. So we're trying to find this height up here, which again, if it was all the way to the ground, that would be easy. We would just look at the bigger triangle. But they gave us two triangles, a bigger one and a smaller one, because we're going to have to find two different answers and subtract them. So again, we're going to find the two heights, one for the bottom height from the bottom of the balloon to the ground, and then from the top of the balloon to the ground. So let's start with the top. Build a triangle, and we know that looking to the top is 53 degrees. We are 60 feet from the balloon. And again, we're looking for x, which I called x. I used just any variable to represent the ground all the way to the top of the balloon. So we have opposite and we have adjacent, and we know that we're using tangent. So I went ahead and did the math here just really quickly, since we did several examples of this already, and I ended up with multiplying 60 times tangent of 53, and I just typed it into the decimals calculator to save some time and got 79.6 feet. Again, that's not our answer yet. We need to now find the height from the bottom of the balloon to the ground. So again, filling in our information, the angle of elevation looking up to the bottom is 29. We're still 60 feet away, but now I'm going to call y my new variable from the bottom of the balloon to the ground. And we're still using tangent, opposite over adjacent. And again, we're going to type in 60 times tangent of 29. I typed that into the decimals calculator, and I ended up with 33.3 feet. So again, we found our two answers, top of the balloon, bottom of the balloon. Now let's find out what the actual height of the balloon is. So our last step here, to find h, we're going to subtract x and y. So x minus y, 79.6 minus 33.3, we end up with our height of our balloon, and that is 46.3 feet. So this is a challenge problem because you had to do multiple steps to get to your conclusion, to your answer. So again, there will be a problem like this on the assignment. You can feel free to try it out. Just, again, remember all of these assignments are for you to kind of enrich yourself for getting ready for next year. I understand that it may be challenging, but again, all I'm looking for you is to try. Okay. So again, hopefully these examples help, that it's something else that you can look at for furthering your knowledge in trigonometry. Again, the last video of this series today will be the actual assignment. Just try them out, try your best, and hope you have a good day.